Documentation for DIY tasks serve as codified project knowledge and help makers reach new understanding and appreciation for the artifact. Engaging in reflective processes using the documentation can be challenging when it comes to physical objects, as the documentation and the artifact exist separately. On the one hand, we have the physical object. By examining the physical object, we typically understand some of the object's qualities, such as its materials, weight, or fabrication technique. But we do not get a rationale of the decisions that went into the building of the object. On the other hand, we have their documentations. These documentations usually contain more details on the object, such as the inspiration behind it or how it was built. However, documentation on their own does not portray the full image of what the final object is. In this paper, we ask if embedding their documentation onto the object being made will promote self-reflection and whether this facilitates a deeper understanding of the object and its design process. Our assumption is that by embedding their documentation information into the object itself, we could gain in situ access to the information, facilitating easier reflection for end users of the documentation. From past literature, such as process products and spin, we know researchers have developed systems to embed data into the physical object to enrich the object. These projects demonstrate how this embedding can be done through different fabrication techniques and how it can create a better link of communication between the maker of the object and its end user. However, these projects have not focused on documentation and how people might organize and share documentation information in their built objects. We conducted a preliminary study where we examined 4 popular examples of online documentation and interviewed and brainstormed ideas with hobbyists and professional makers. From that, we gathered several design guidelines for developing a prototype system. We introduced Documented, an application that helped makers associate documentation to 3D printed objects. Let's imagine Brian. Brian teaches fabrication at the design school. To show examples of his design to his students, he used Documented to create an in-situ documentation of his mini amplifier. He 3D printed a few copies of the mini amplifier to pass around the classroom so that the students can read the documentation while exploring the object in their hands. Step 1. Brian opened Documented, where he saw that the system had 4 tags to which he could attach multiple media format of files. He used the tags to organize his information and decided to divide his documentation information based on the amplifier's model's 4 main components. Step 2. Brian was redirected to a Tinkercad sketch where he imported the 3D model of the amplifier and found 3D models of the 4 tags he had used previously and placed them on the model. He has the flexibility to choose any shape or location for the tags. After positioning the tags, Brian exported his model with the tags as an STL file and sent it to the 3D printer. Step 3. On the day of teaching, Brian distributed the amplifier models to the students who then, using mobile AR, read about the documentation information and explored the model in their hands to better understand the design process. For evaluation, we invited 12 participants to explore a pre-built object and the documentation materials that we had collected about it. We asked them to use Documented in order to present how they would document their pre-built object using the system. We found that associating documentation information with physical tags that got embedded in the printed objects helped people reflect on 3 aspects of the process and the object. 1. Documentation structure. How would they approach organization of the documentation data and the different categories that they would use? 2. Objects aesthetics. Physicalization of documentation information also requires consideration of their aesthetic-related decisions in the objects. 3. Personalization of information sharing and appearances. Makers prefer to separate what could be visible to the general public from information that should be visible to other makers. In the future, we are interested in examining how students might use our prototype in educational contexts to develop and transfer knowledge. We would also like to explore how such documentation might be perceived by users of mass-manufactured objects in the home context. For example, by embedding information such as instructions to construct and deconstruct IKEA furniture. If you'd like to learn more about our findings, make sure you have a look at our paper. Thank you.